Hello dear student, I am Mordern Islam. Today in this video we are going to discuss three important questions of GATE 2022. Okay, so first question, the number of non-isomorphic abelian group order this. Okay, for this question we have to remind a result first. We have to recall the result. If GBA group of order n, and if n is an integer, we can prime factorize this. Okay, I am prime factoring this. Suppose prime factor of n be like this: p1 power alpha 1, p2 power alpha 2, and pr power alpha r, right? Where p1, p2, pr are primes. p1, p2, pr are primes. Okay, and alpha 1, alpha 2, alpha r, alpha 1, alpha 2, alpha r are positive exponent. Then the number of non-isomorphic abelian group order n equal to partition of alpha 1 first prime powers alpha 1 into partition of second prime power alpha 2. You have to product this in partition of last prime power p alpha. Okay, this is the final result. So for this problem, it is given that n it is n 2 power square, 2 power cube, and 5 power 4. For this problem, it is given n equal to 2 power square, 3 power cube, 5 power 4, right? So alpha 1 equal to 2, alpha 2 equal 3, alpha 4 equal to alpha 3, alpha 1, alpha 2 is alpha 1, alpha 2, and it is alpha 3. Okay, so we have to find the partition of 2, 3, and 4. These are all prime 2, 3, 5. Okay, what is the partition of 2? See, partition of 2 can be written like this: either 2 plus 0 or 1 plus 1. So in this case we have 2 partition. Okay, in this case we have 2 partition, means partition of 2 equal to 2. Okay, now 3, for 3 this alpha 1, right? And alpha 2 equal to 3. Partition 3 can be 3 plus 0 or 2 plus 1 or 1 plus 1, this 3. So partition of 3 equal to 1, 2, 3, 3. Now what can be partition? Alpha 3 equal to 4. Partition of 4 will either 4 plus 0 or 3 plus 1 or 2 plus 2 or 2 plus 1 plus 1 or 2 or 1 plus 1 plus 1. So in this case we have 5 partition. So partition of 4 equal to 5. Okay, so what is the number of non-isomorphic abelian group order this equal to product of partition of 2 into partition of 3 into partition of 4. Okay, so final result will be partition of 2 into partition of 3 and partition of 4. Partition of 2 is 2, partition of 3 is 3, partition of 4 is 5. 30 should be answer. Okay, so for this problem 30 is the answer. So number of non-isomorphic abelian group order this equal to 30. Now come in the second problem. The number of subgroup of cycle group order 12. Okay, suppose GBA group of order 12, and it's given that suppose GB the group order 12 and given that G is cyclic. Okay, G is cyclic. It is given, suppose GB the group order 12 and it is given that G is cyclic. Since G is order 12, it obviously that G is finite, means G order G is 12 means G has 12 elements. In this group there are 12 elements, so obviously it is a finite group. Okay, we know that finite cycle group order n, if it is n, suppose 12 is n, any finite cycle group order n is isomorphic to Zn. So since any finite cycle group of order n is isomorphic to Zn, so since G is a finite cycle group order 12, so this is the isomorphic to Z12. Okay, now we know the number of subgroup of Zn, number of subgroups of Zn equal to tau n. Tau means number of divisor by n. Tau means number of divisors of n. Okay, so number of subgroup of what is the number of subgroups of G equal to tau 12, right? So divisor of 12. What are divisor 12? 12 divisor is either 1, 2 or 3 or 4 or 6 or 12, right? These are 1, 2, 3, 4, 5, 6 divisor. So it has 6 subgroup. So G has 6 subgroup. So number of subgroup or number of subgroup of cyclic group order 12 is 6. Okay, so 6 is the answer. There is one more formula of tau. Okay, we know this. I'm telling you for this knowledge purpose. If we suppose if we have n equal to p1 per alpha 1, p2 equal to p per alpha 1, p2 per alpha 2, and p alpha alpha, where p1 p2 p are primes and alpha are positive exponent. This power is positive. Then number of divisor of n, tau n. What is the formula? Alpha 1 plus 1 into for this alpha 1 plus 1, because if suppose if a number is divide this 12 product, then it should be divide either divide this or divide this or divide this. So if you divide this, then the total number divisor of should be can be alpha 1 plus 1. Okay, for this alpha 2 plus 2, alpha 2 plus 1. So we have to product this. So tau n equal to alpha 1 plus 1 into alpha 2 plus 1 into alpha r plus 1. This is the formula. Okay, so what is the tau 12? In this problem with tau 12, 2 square into 3, right? 4 and 30. So 4, 4 and 12. So alpha 1 is 2, alpha 1 is 3. So alpha 1 plus 1 means 2 plus 1 into alpha 2 plus 1 means 1 plus 1. 2 plus 1, 3, 3 plus 1, 6. So in this case, 6 subgroup. And what are the subgroup? You can also find the subgroup because Zn is cyclic. Okay, we know Zn is cyclic. In a cyclic group, for each divisor n, there is subgroup. There exists a subgroup of Zn such that order is equal to this divisor. Okay, and not only this subgroup is unique. This subgroup is unique. In Zn is a finite cyclic group, so for each divisor n, there is a unique subgroup of that order. Okay, so in this problem we have 12 is divisor either 1 or 2 or 3 or 4 or 6 or 12. So what are the subgroup order on? Is Z1. Z1 means only 0. What is subgroup order 2? This means Z2. Z2 means 0, 1. I am doing this for knowledge purpose. Okay. Z3, 0 bar, 1 bar, 3 bar, 2 bar. Subgroup order 4, Z4. Subgroup order 6, Z6. It will be Z6 because we know in subgroup of cyclic is cyclic. Okay. Since order G is 12 and G is cyclic, so all subgroup of it is cyclic. Subgroup of a cyclic group is always cyclic. So 6 order subgroup always will be Z6, not S3. Okay, because S3 is non-cyclic. And 12 order cyclic subgroup is Z12. Okay, these are subgroup. The subgroup of G will be Z1, Z2, Z3, Z4, Z6, Z12. Okay, these are 6 subgroup. These are the total subgroup of G. Okay, you have to mark only the answer in the exam. Okay, not the subgroup. Next question. The initial problem dx is equal to cos xy, y0 equal to y0, y0 is real constant. This is either any solution is a solution. There are 4 options. Any solution is equal to solution, infinite solution, no solution. Okay, so to mark one question, mark answer. Okay, so for this I am writing a result. We know the initial problem dx is equal to fxy, where y0 equal to yx0 equal to y0. This yx0 equal to y0. This is initial problem. Okay, IAP. Initial problem. This has solution. You can name it 1. The 1 has solution. 1 has solution if f is continuous. Okay, f should be continuous. Then this initial problem dy is equal to fxy, y0 equal to y0 has solution. Further, this solution is unique. If f satisfies Lipschitz condition, or you can say that del f del y is bounded. If del f del y is bounded, then it automatically satisfies Lich's condition. Then this insoluble problem has unique solution. Okay, so for this problem we have dy is equal to cos xy and y is y0 equal to y0. So I am writing this. Dy is equal to cos xy. Okay, so here fxy will be cos xy. Okay, cos is the given function, it is continuous. Okay, cos is the given function, so it is continuous. So this insoluble problem clearly has a solution. Okay, always has a solution because fxy is continuous. This function, because f is continuous. Since f is continuous, this always have a solution. Now we have to check whether it is a unique solution or infinitely or no solution. No solution is not possible because since f is continuous, so it has solution. So 4 option is incorrect. So either 1, 2, 3 may be correct. Okay. Now if we check either it is unique solution or equal to solution or infinite solution. So we have to check either delta is bounded or not. Okay, we have to check delta is bounded or not. What is f? Cos xy. Okay. So what will be delta partial derivative through y? Minus sin xy x into 1. Okay. Now if you take mod inside, then it will give you mod sin xy into mod x, right? Mod sin is always less equal to 1 for any real number x and real number y real number, so total is real number. So mod this will be first of all write mod a into b, mod a into mod b. So you can write this mod sin xy into mod x. Now mod sin is always less equal to 1, so you can write this less 1 into mod x. Okay, so it will be less equal to mod x. So del f del y will be less equal to mod x. Now we know for initial problem, if we suppose we have the condition like this, y0 equal to y0. Okay, so what will the region or rectangle? The region will be R such that mod x minus x0 has 0 less than a. Okay, and y minus y0 should be less than b. So in this case mod x should be less than equal to a. Okay, so mod x should be less than equal to a. So it implies delta y bounded. Okay, delta y less than some real number, right? So delta y is bounded. Since delta y is bounded, so this insoluble problem, the given insoluble problem has unique solution. Okay, by Picard theorem. The result, this result is called Picard theorem. Okay, so this insoluble problem has unique solution. So equal to solution not correct, infinite solution not correct, so unique solution. So option A is correct. Okay, so thank you.